Let's look at this problem. Values for A, B, C, and D are to be selected from the set of 1, 2, 3, 4, 5, 6 without replacement. That is, no two letters have the same value. How many ways are there to make such choices so that the two curves y equals a times x squared plus b and y equals c times x squared plus d intersect? The order in which the curves are listed does not matter, which means that it doesn't matter which equation or which curve comes first. Before we dive into this problem and start trying to do the counting, we have to understand this statement well enough. This is the key part of this problem. What does it mean these two curves intersect? Why are they related to the choices of A, B, C, D? And we have to understand that well enough. Because obviously, some choices or some combinations of A, B, C, D doesn't satisfy this condition. And there are two ways to handle that. One is to list the two expressions as a system of equations, and then try to determine when this system has solutions and when it doesn't. And the other way to handle this is simply draw the curve, because we know that these two curves are parabolas. So we can check the curve and see how the coefficients affect the shape of the curve so that they can intersect or otherwise. In this video, we'll take the second approach. We'll start from the curve, and then let's see how these coefficients affect the shape of the curve. Alright, let's draw it out. Suppose this is our coordinates, right? And this is y-axis, this is x-axis. And let's look at the curve. Let's look at the first curve. Y equals ax squared plus b. So what does this b mean? We know that this b means how much we lift this curve along this y-axis, right? So for example, if b is here, this parabola shall look like this. It's sitting right at the point of b, and the curve is symmetric to the y-axis. Basically, we know that b tells us how high we place this parabola. Then what about a? We know that this a tells us how steep these curves goes up, or in other words, how wide this parabola is. We know that the larger the value of a is, the steeper are these curves. So for a bigger a, we shall see a curve like this, right? This is for let's say larger a, and this is for smaller a. So when a is larger, the parabola has a very narrow opening and the curve goes up quickly. And for a smaller value of a, the parabola can be a little bit flatter and the opening of the parabola is a lot wider. So with that information, we can study why these two curves or why two parabola can intersect. So let's first write down this property of a. So a tells us how wide is the opening of the parabola. Okay, so now let's clean up the chart and we'll draw the two parabolas. And then let's see why they intersect and why they don't sometimes. Okay, so let's redraw this y-axis, right? Since we take the values of a, b, c, d without a replacement, so certainly for these two curves, y equals ax squared plus b and y equals cx squared plus d, the value of B and D are certainly different. So we can assume, let's say B is greater. So let's say B is here. And let's say D is here, right? And now we can draw these two parabola. But how can they intersect? Do you want the narrow or steeper parabola on the top or on the bottom? So I think the answer is obvious. We want the steeper parabola to be on the bottom and want the flatter parabola to be on the top. So it should be like this, right? We want the lower one to be on the bottom and the wider one or the flatter one to be on the top. Let's say this is B. This is B, right? This is for the A curve, right? The first curve, ax squared plus b. And if this is for the cx squared plus d, y equals to this and y equals to that. And then we know that we want this A to be smaller than C. Then the two parabola intersect each other. And otherwise, if we put the narrower or the steeper parabola on the top, then the two parabolas will never intersect, right? It's straightforward to imagine that. So I'll draw two curves to illustrate it. So if we have a steeper parabola on the top, let's say it's like this, and have a flatter parabola on the bottom, let's say it's like this, then we know that these two pink curves will never intersect, right? Because the lower one will go flatter and flatter, and the top steeper parabola will go very steep and very fast upward. Okay, so with this information, I'll put the conclusion here. So we want this. When B is bigger, and we want this A to be smaller, and vice versa. When C goes smaller, or C is smaller, and we want this D to go bigger, because we want the lower parabola to be steep and to have a narrow opening. Good. Now let's come back to our counting. So first of all, we need to choose 4 numbers out of this set of 6. Then we have 6 choose 4 many selections to place the A, B, C, D, right? And for the given A, B, C, D, we need to select 2 numbers out of the 4 to place them as the coefficients of the x squared. Then we have 4 choose 2. And once that's decided, we are pretty much done. Why is that? Because, for example, if we choose B and D as the coefficients of x squared, then certainly we want the bigger one. Let's assume A is greater than B, greater than C, and greater than D. Okay? And we want the bigger one to pair up with the smaller constant, which means that the B has to pair with C, right? Then that represents the steeper parabola on the lower place. And the other 2 numbers, D pair with A, which gives the upper parabola to have a wider opening or have a flatter shape. Therefore, as long as we've picked these 2 coefficients, then everything is fixed. Alright, therefore, this is the total number of ways that we can set up these 2 curves or these 2 parabolas so that they intersect. Therefore, this equals 6 factorial over 4 factorial times 2 factorial times 4 factorial over 2 factorial and 2 factorial. So we cancel out these 4 factorials. And then we have 2 times 3 times 4 times 5 times 6 on the top, right? That's 6 factorial. And on the bottom, we have a product of 3 2 factorials, which is 8. And we cancel this 8 with 2 and 4. And then we have 3 times 5 times 6, right? 3 times 5 times 6. And these two gives 30 times 3, that's 90. Therefore, 90 is our answer. So we will choose C. If you like this video, please give it a like and subscribe to the channel. If you have questions, please leave a comment.